So today we're going to take slope into the real world a little bit further. Our objective is to apply slope to real world problems. And to be perfectly honest, basically we're going to be talking about rate of change, which we talked about in our last video. And rate of change is just slope with units. It's a unit rate with units. So today we're going to go and find out where do we see this in the real world. So you might remember back on page 172, we talked about linear relationships. We talked about in a table, as long as that slope, which is the rise over the run, the change in y over and change in x, as long as that stays the same from one point to another point, to another point, to a fourth point, to a fifth point, if that slope, which is change in y over change in x, 2 over 1, stays the same, then if you plotted these points, it would be linear. It would be a line. We talked about that as being a constant rate of change, a constant slope. If at some point that changes, then no longer is it in a straight line. It would kind of start to be like a lightning bolt. So remember that the slope formula, you're going to take a y coordinate minus a y coordinate over the x minus x. That gives you slope. We're going to take it one step further again and divide the top by the bottom to get a unit rate. We're going to make sure our units are in there, and that's what we're talking about today, guys. So it's really a review of slope, and we're just going to use it in the context of some real-world examples. Now, back to that slope lesson on page 183, and there was a table. Remember, this is going down 3 pages for every 2, down 3 for 2, down 3 for 2. The slope would be a negative 3 over 2. If you take 3 and divide it by 2, you would get a unit rate of negative 1.5. So basically, the amount of pages left is going down by 1.5 for every minute of reading. That slope change to a unit rate with units is called rate of change. And remember that in a linear relationship, it doesn't matter what 2 points you pick, you will get the same slope. So if you had taken 12 and 3, 12 minus 3 would give you a 9, and 1 minus 7 would be over negative 6, and that would reduce to negative 3 over 2. So when your points are linear, it doesn't matter which 2 you pick, but to be honest, it's easier math if you kind of pick them close together. Okay, so that was kind of just a review of what we've done so far, so let's take it further. So here's a real-world example. The table below shows the weight of a dog in pounds between 4 months and 12 months old. Assume the relationship is linear. So if we know it's linear, then we know there has to be a constant rate of change. The slope is going to stay the same throughout the points. We're going to use the information in the table to find that rate of change in the dog's weight between 8 and 12 months old. So right here, between 8 and 12 months old. So the first thing you have to decide is, what is y and what is x? Now, we've talked about this before. What depends on what? Does the weight of the dog depend on his age? Or when you put him on the scale, does his age miraculously change based on his weight? Right? No. His weight depends on his age. So the dependent variable y would be his weight in pounds, and the independent would be his age in months. And remember, I kind of let you know that most of the time, not always, most of the time, if time is involved, days, months, seconds, years, weeks, that usually is x, not always. Okay, so you're going to pick 2 points. And in this case, we're picking the x, y, 8, 28, and the 12, 43, because, we want to find this rate of change. How is the puppy growing? What's happening to his weight as he gets older? I mean, that's the question we're asking. So his change in weight in these 2 points in time would be y minus y. Remember to leapfrog over the x's. The top of the slope formula is to take a y minus the y. And I would write it 43 minus 28. And I'm going to remember this is pounds. That's my unit for the y's, right? And now when I go to do the x's, I have to start with the x, whichever one I started with, which in this case was the 43. So I'm going to take 12 minus 8. And that would be months. So when I pick up my calculator, 43 minus 28 gives me 15. and 12 minus 8 gives me 4. So he is basically gaining 15 pounds every 4 months. And we kind of say, well, that's great, but I really would like a unit rate. What's happening every single month, every 1 month, right? Uno, 1 unit. So in order to get that unit rate, unlike slope with rate of change, we're going to take the top and divide it by the bottom. So pick up our calculator. 15 leads the way into the calculator. Divide it by 4. And this dog is growing 3.75 pounds per month. Rates of change always have units. Pounds per month. It will have a Y unit and an X unit. A rate, 2 different units. Okay, so let's talk about what about if we were on a graph. So I'm going to ask you right now to see if you can find the slope of this graph. Okay, we got to be really careful here. As you're going to see, there's kind of a be careful with block counting on real world graphs. So we're going to start here by picking 2 points. So I picked 0 miles, $4, and 5 miles, $8. Now, what is this? This is the cost of a taxi. So the charge depends on how many miles you go in this case. When I go to calculate slope, I'm going to take y minus y, and I'm going to do the 8 minus 4 to try to keep this positive if it is, and then over 5 minus 0. Is everybody okay with that? Y minus y over x minus x. 8 minus 4 is 4, and 5 minus 0. That would be our slope. Now, this is a real-world problem, so I need it to be a unit rate, and I need units. So you're going to take the top. The numerator leads the way into the calculator, 4 divided by 5. Some of you already know what this is in decimal form. Check yourself in the calculator. 4 divided by 5 is going to give you 0.8. And it will be the top unit is your Y unit. Remember, Y is in the top, which would be the charge, which would be dollars per mile. So basically, this taxi ride is costing you 80 cents for every mile you go. And that's called a rate of change. Guys, it's a slope written as a unit rate with units. It's just slope with units. So how about if we take a look at page 186? You're going to notice for problem number 10, I am putting the title in. This is Sophia's earnings. And for working 3 hours, she earns $30.60. For working $5, she earns $51. For working $6, she earns $6.21. What is the slope of the line? It's linear, see? And so I plotted the points. Here they are. And we need to find the slope of the line. So I would use my points here for sure, which reminds me of something I will go back to in a second. So anyway, I got to pick 2 points up there. Notice the dollars depends on the hours. So earnings, the dollars is your Y, and hours is your X. And they actually gave you too many points up here. I'm going to take that, the 51 minus the 30.6, and the 5 minus the 3. So dollars minus dollars, hours minus hours. I pick up my calculator. I get $20.40 on the top over 2. So basically, she's earning $20.40 for every 2 hours. We want it as a unit rate. So let the 20.4 head into the calculator first, divide it by 2, and she is earning $10.20 per hour. I forgot to say something about these units. I'm going to go back for 1 second. But what you really have to be careful is a lot of people will just look at the points and let's say, oh, rise over run, 1 over 2. You have to be careful when block counting. This is not $1. This is $4. So every block going up is 4. Every block going across is actually 2.5 miles. 2 of them would be 5. So do you see the 4 over 5? A lot of people would make a mistake on this, just go, oh, it's 1 over 2. You've got to be careful and look at your units. Now, this one, it's impossible to use. And again, these would be 10, 20, 30, right? Are you with me? But it's impossible because these points are not in the crosshairs. So we really have to use the slope formula. Okay, so what in this particular case does the slope of the line represent? What is this $10.20 per hour? That is what she earns every additional hours she works. She works another hour, she'll get 10.20 added to her paycheck. She works 2 hours, she'll get two $10.20 added to her paycheck. Okay, so let's just do now, we've done a table. We've talked about a graph. Now, what if everything is in words here? So a Biggest Loser contestant, I don't know if you've ever said, there used to be this show on TV where people would come in and they wanted to lose weight and they were heavy. It wasn't just a few pounds. So you can see that this particular gentleman came in at 335 pounds. So that's what he started at. He comes back in 6 weeks later. He's down to 173 pounds. First of all, what depends on what? And then we are going to find what is his rate of change. Okay, what is happening to his weight? So what is the X and what is the Y? That's the first thing when you're looking at words. So does his weight depend on how many weeks have gone by? Or does the week change based on his weight? Think about that. So in this particular case, again, weeks time, it's usually X, okay? Our pounds are going to be our dependent variable, which is our Y. And our weeks is going to be our independent variable, which is our X. So I can see a point very easily here. Do you see it? 6,173. But what X goes with the 335 pounds? At the start, how much time has gone by at the start? And you should realize no time has gone by, so that would be 0 weeks. Okay, so let's just take a look at this one. So X is going to be the weeks, and Y is going to be the weight in pounds. And you and I just came up with the fact that these are our 2 points. Okay, you have a job right now. Can you please calculate the rate of change from the start to 6 weeks later for this gentleman? Okay, so how do we do that? You should have taken Y minus Y over X minus X. So 173 minus 335 in the calculator and 6 minus 0. Is everybody okay with that? Now, before we go anywhere, this guy lost 162 pounds in 6 weeks. Now, a rate of change needs those units, but it also needs to be a unit rate. So take the top divided by the bottom. We do that when it is a real world problem. If it was just slope, we would just simplify it and leave it. Okay, divide the negative 162 divided by 6, and you're getting negative 27 pounds per week. He is losing 27 pounds per week so far. Will this continue? Will this relationship stay linear? At some point, you're going to say, hey, wait a minute. There is no way that somebody's going to keep losing 27 pounds per week. And you're right. So up to this point in time, this has been a linear relationship, but it's going to level off, right? At some point, this could be it. He could be at his ideal weight, and this would no longer be happening. Okay, I'm going to let you finish this last one all by yourself, okay? So a plant was 4.5 centimeters tall on December 9th, and then on December 16th, the plant was 8.7 centimeters tall. Identify the independent and dependent and find the rate of change. Go ahead and get started, and let's see how you do. Okay, so independent, dependent, your X should have been the number of days. Your Y should be the height in centimeters. Make sure you put your units in there, okay? The height depends on how many days have gone by, not the other way around. So now we need 2 points. And now I'm going to caution you, there are 2 ways to do this and get the right answer. So you could put that on December 9th, it was 4.5. And since it's the same month, you could say on December 16th, it was 8.7. The other way that some people will do it is they'll say, well, at the start, I'll make this 0. And then 16 minus 9, 7 days later, and they put a 7 here. You'll get the same answer either way. You have to be careful if we went from December to January, because you couldn't just subtract them to get the number of days. Okay, you would have to kind of think about that. Alrighty, change in Y over change in X. So I'm going to take Y minus Y. Oh, by the way, slope. I think I said it kind of in passing. I should have said that before. Slope is abbreviated as the letter M for, think of it as mountain. I once Googled it and it basically said they're not exactly sure, but they think it has to do with the French word for mountain, which also starts with an M. Um, and it goes back to a gentleman named Descartes who actually came up with the whole XY coordinate plane. So they use M. I remember saying this in a previous video. They don't use S because S is used somewhere else. So M is just a shorthand for the word slope. Okay, so I'm going to take Y minus Y over X minus X. I pick up my calculator. It's 4.2 for the top and 7. Basically, what does this mean? The plant grew 4.2 centimeters in 7 days. We want a unit rate. What's happening for 1 day, not 7? Take 4.2, divide it by 7 in the calculator to get a unit rate. And this plant is growing 0.6 centimeters, just bigger than half a centimeter per day. And that is called a rate of change. A rate of change is your slope written as a unit rate with the units. So today we're just taking our y2 minus y1 over x2 minus x1 called slope, abbreviated as the letter M, and we're making it a unit rate, putting our units in to see where does slope, oh, by the way, rate of change, get used in the real world. It's going to be time to practice once I see you and we do a few problems together. I hope you all have a great day.